that we are going to discuss now. That means initially what is the behavior of the inductor, and at finally what is the behavior of the capacitor or inductor. That all we are going to discuss now. So yesterday I have given clear instruction about joining in the class. So everyone should join with a register number. Then only it is possible to take attendance properly. But no one can join like that. You are joining with your whatever the name, that name you are joining, right? So please try to change your name, all of you, for the next class onwards. Right, is it visible?
Yes, sir.
Okay, right. Yesterday we had discussion about how to find initial conditions for three elements: resistor, inductor, and capacitor. Now, how it is possible that we can see for individual elements. So before going to that, once again, I recall the last concept about transient conditions or initial conditions. Coming to the first one, when you take t is equal to 0 minus, it indicates the time of switching between minus infinity to 0, or we can say it is a time before. If you take t is equal to 0 plus means this is the time of switching at the instant just after time. That means after immediately closing the switch, that indicates t is equal to 0 plus. T equal to 0 minus means before switching. T is equal to 0 plus means after initially or immediately closing the switch, what is the response? Now last one is t is equal to infinity. This is the time of switching, and you can consider between from t is equal to 0 plus to infinity as taken as the final value. So to understand what is t is equal to 0 minus, t is equal to 0 plus, t is equal to infinity, if we clearly observe this one. So this is a 0 point. So from minus infinity to 0, you can take this as 0 minus. And at t is equal to 0 plus, this is the value. And from 0 to infinity, you can take, or you can call for it is t is equal to infinity. So we are always discussing about this one. This is the main point. Before switching close, after immediately switching close, and at t is equal to infinity. So while discussing about these initial conditions, you have to remember only three conditions for t is equal to 0 minus first. So first one is t is equal to 0 minus, that is before switching. And the next condition you have to remember is t is equal to 0 plus, that is after closing the switch immediately, what is the behavior. And finally, we can calculate the values at equal to infinity. Infinity in the sense, we can call it as final. We can call it as final. So that we have to remember these three conditions. For t is equal to 0 minus, t is equal to 0 plus, t is equal to infinity. So based on these three conditions, how the network elements can behave in any circuit, that is what we are going to discuss now. If you know that behavior of the elements in any circuit, then it is very easy to analyze any kind of circuits. Coming to the first one, resistor. Here I am going to recall the relationships between the network elements. If we take resistor, what is the relation between voltage and current? If we take inductor, what is the relation between voltage and current? If we take capacitor, what is the relation between voltage and current? So if we take a resistor, And V of t is the voltage of the resistor, that is we are going to apply, where I of t is the current through the resistor. So according to Ohm's law, we can say V of t is equal to R into I of t. Or if you want to write the expression in terms of current, I of t is equal to, I can write V of t by R. Similarly, if you're coming to the inductor, so again I am going to take an inductor with the voltage of V of t and the current through the inductor is I of t. That time the relation between voltage and current to the inductor is V of t is equal to L into di by dt. And if you want to calculate I of t, then take the integration on both the sides from 0 minus to t, then I will get I of t is equal to integral of 0 minus t to t V of t to dt. So that you have to remember both the equations. Inductor element with respect to both the voltage and current, either V of t is equal to L di by dt or I of t is equal to, there should be 1 by L, that is missing. So 1 by L integral V of t into dt. So this is over here. So I of t is equal to 1 by L integral V of t into dt. If we consider initial conditions, there we can add this one, IL of 0 minus. This is for an inductor. You have to remember both relationships, both voltage and current. Coming to the capacitor, here also we are taking capacitor and I am going to apply voltage V of t. Let the current through the capacitor is I of t. Now the relation between voltage and capacitor voltage and capacitor current is V of t is equal to 1 by c integral I of t into dt. And if you want to calculate current I of t over here, then take the differentiation on both the sides. I will get I of t is equal to c dv by dt. Right. Now how to find initial conditions in network elements? So let us take the first element is a resistor. So for every time I am going to take the supply voltage is V of t and there should be a switch. This is a symbol of switch. Now the current through the circuit is I of t. This is nothing but I of t. And the element value should be R and the symbol is represented like this. So before closing the switch, that is at t is equal to 0 minus, when you take this resistor, before closing the switch or after closing the switch, there is no change in the current because the resistance function is always opposite the flow of electrons. Therefore, the switch cannot change. That means there is no change in the current even though if you close the switch for the resistor, because the resistor is a independent of time t element because it cannot store the energy, right? So the initial conditions and the final conditions does not applicable for the resistor element because it is a constant value and which does not store the energy in the form of either electric field or magnetic field. So for that, it does not have any initial value or final value, and we do not consider initial conditions or final conditions for resistor. No need to consider. Coming to the inductor. So that is for resistor. So for t is equal to 0 minus and for t is equal to 0 plus and for t is equal to infinity, we do not consider this type of conditions for the resistor because it is not storing the energy, so that we cannot vary the response with respect to time t. So no need to calculate for the resistor. So there is no initial condition or final condition for resistor value. Coming to the inductor. Again, I am going to take voltage V of t with the switch. Current through the inductor is I of t and inductor value I am going to take L. Here we have one switch. Now I can call this as a switch. And we are having t is equal to 0 and the arrow mark shows like this, right? It indicates the switch is closing at t is equal to 0 instant. When I close the switch is equal to 0 instant, what is the current in the inductor? Before closing the switch, what is the current in the inductor? That is what initial condition. After long time, if you close the switch, what is the behavior of the inductor? So that we are going to calculate 3 time action in the inductor. Right. When the switch is closed at t is equal to 0, the current through the inductor cannot change instantaneously. So as a result, closing of a switch to connect an inductor to the source of energy will not cause current flowing through the inductor at the instant, and inductor will be act as a open circuit. That means when I take this one, I of t is equal to, we have the expression 1 by L. Now this is the duration between from minus infinity to t. That means if you take the graph, this is I'm going to represent from I'm always taking the duration of the signal, current or voltage, whatever it is, from minus infinity to 0. Now minus infinity to 0 can be split into two parts. That is from minus infinity to 0 minus, and from 0 plus to t. This is what we are going to take. So if I take for an inductor, I of t is equal to 1 by L, integral from minus infinity to t, v of t into dt. Now I'm going to split this integration from minus infinity to 0 minus, and from 0 minus to t. So from minus infinity to 0 minus means the switch is open. So the switch is open in the sense I can take this as 0 minus, that is I of 0 minus. Next one is 1 by L integral minus 0 to t v of t into dt. Now take t is equal to 0 plus on both the sides. I will get the expression is like this. That means I of 0 minus integral from 0 minus to 0 plus v of t is equal to 0. In both the cases, I of 0 plus is equal to I of 0 minus. That is, if I of 0 minus is equal to 0, then I of 0 plus also 0. This means the inductor acts as an open circuit before closing the switch as well as after immediately closing the switch. So if you want to clearly know about this one, that means before closing the switch, what is the current in the inductor? That I am going to take I of 0 minus. Before closing the switch, what is the current in the inductor is I of 0 minus. What is the current in the inductor? So generally it is 0 because there is no closing switch. If there is open in the switch, no current is passing through the inductor. Then after immediately closing the switch, that is when you close the switch, then immediately again what is the current in the inductor? That shows I of 0 plus. I of 0 plus. So when you close the switch at t is equal to 0 plus, then what is the action in the inductor? Is there any current passing through the inductor? That is also to be 0 because yesterday we had introduction, we had discussion about before closing the switch, after closing the switch, the response is to be same. That means when you're coming to the inductor, before close the switch, the inductor current is 0. After immediately closing the switch, again the current through the inductor is 0 because that inductor does not allow sudden changes in the current. So therefore, in both the cases, I of 0 minus is equal to 0. I of 0 plus is equal to 0. Then after some time, that means up to infinity, that is after charging, fully charging of an inductor, what is the current in the inductor? Then the time the inductor will behave like a short circuit, but when you close the switch, initially inductor will be act as a open circuit. That I can show here how it is possible, right? So initially when you close the switch, the inductor will behave like an open circuit. That means inductor will be taken as an open circuit because at t is equal to 0 plus means that is the current I of 0 plus is also 0. Therefore, no current is passing through the inductor. That's why it should be act as an open circuit initially. Now, same inductor with an initial current, if you want to represent, then it is to be an inductor can be replaced by a current source I0 initially. This is only for initial condition. Now, at t is equal to infinity, that means after fully charging, that is final condition or steady state condition, after finally fully charging, this inductor will be act as a short circuit. So this inductor, this is an inductor symbol. There should be, it should be act as a short circuit in the sense we can draw a straight line in place of inductor. Why this inductor will be act as a short circuit means, then we know the inductor voltage V. That is V is equal to L into di by dt. So V is equal to L into di by dt. Where coming to this one, at t is equal to infinity, when I substitute t is equal to infinity over here, then I will get L into di by infinity. L into di by infinity. So any value is, something value divided by infinity is nothing but 0. Therefore, the voltage of an inductor is 0. If the voltage of any inductor or resistor or capacitor is 0, then it will be act as a short circuit. Therefore, initially inductor act as a open circuit. So open circuit is always represented like this. And steady state means finally this inductor will be act as a short circuit. Short circuit in the sense we have to draw a straight line. This is the behavior of an inductor. Similarly, if you coming to the capacitor, how the capacitor initially act, and at steady state how the capacitor will be act. So remember, if I take a phone, yesterday we had a discussion about mobile phone charging. So let us take the phone or an inductor. Sorry. So I'm going to take this as a T, and this should be charge. That's a mobile charge. I can take this is nothing but current through the inductor. Let us assume that. So T is equal to 0. Initially inductor current is 0. That is at T is equal to 0 minus or 0 plus. When you close the switch, immediately this inductor current is 0. Now I'll keep on increasing time T, 1 second or 2 seconds or 1 hour or up to 10 minutes or 100 minutes, whatever it is, 100 minutes. So while doing this one, the current through the inductor keep on rising and keep on rising. It can store the maximum energy at 100 seconds or 100 minutes, whatever it is. So it can store the maximum energy at this point. Now I can consider this is for infinity term. I can consider this is for infinity. That is, as per mathematical knowledge, we can take this is an infinity. T is equal to infinity. So this is for T is equal to infinity. So at T is equal to 0 plus means what is the current in the inductor? It is to be 0. So therefore at T is equal to 0 plus, current through the inductor is, that means IL is equal to 0. Now keep on charging, hence the inductor is going to be charged. So the charging in the inductor is going to be increasing up to value and it become maximum stores the energy at T is equal to infinity. Let us assume that. So initially the current in the inductor is 0 means this should be act as a open circuit. That means initially it act as a open circuit. While coming to a steady state, that's a final state. That means it stores the maximum energy. Maximum energy in the sense, what is a inductor? I'm taking it is to be short circuit. How it is to be short circuit? There we can discuss. So at T is equal to infinity means stores the maximum energy means it reached to 100%. The current reached to 100%. That means this graph is for di by dt. So di by dt is not 0 from this portion, from 0 to up to maximum value. While coming to this maximum value, this I will be constant, then di by dt is nothing but 0. That means voltage of an inductor is 0. If the voltage of inductor is 0, then that inductor will be act as a short circuit. That inductor will be act as a short circuit. That means this inductor we can take a straight line. That is in case of steady state or final condition. So at initial condition, initially, that inductor will be act as a open circuit. That means OC is nothing but open circuit. And at steady state condition, this inductor will be act as a short circuit. This inductor will be act as a short circuit because the voltage across the inductor will become 0, so that this inductor will be behaves like a short circuit. So finally, we conclude that initially inductor act as an open circuit and finally inductor act as a short circuit. Then what is I naught? Here is an I naught is there. Then if there is any initial current in an inductor, that time how to inductor can be modified. Suppose there is an inductor current. మీకు ఇంకా క్లారిటీగా అర్థం అవ్వాలరా అనుకుంటే సపోజ్ మీ మొబైల్ ఫోన్ ఛార్జింగ్ పెట్టక ముందు మీ దాంట్లో జస్ట్ 5% కానీ 2% ఛార్జింగ్ ఉందనుకోండి. లైక్ దిస్ ఇస్ టైమ్ టీ. నౌ దిస్ ఇస్ అ మొబైల్ ఛార్జింగ్. If there is a charging in your mobile, even though if you connect that mobile charge into the supply, అది ఎక్కడి నుంచి ఛార్జ్ అవుతుంది? మళ్ళీ 5% ఉంది అనుకుందాం. 5% ఛార్జింగ్ ఉంటే ఎక్కడి నుంచి ఛార్జ్ అవుతుంది? 0 నుంచే స్టార్ట్ అవుతుందా? 5 నుంచి స్టార్ట్ అవుతుందా?
5 నుంచి.
So this 5% is nothing but there is an initial current in the inductor I naught. So that inductor will start charging from 5% onwards. So this initial current is I naught. If initial current is 0, that means charging is 0, the mobile will charge from the beginning. If the initial current is 5 amperes means, so the inductor will start charging from 5 amperes onwards only, not from 0. So that if the inductor with initial current, that means if you take with initial current, that inductor current, I mean, initially you can replace that inductor by the current source I naught, and finally that inductor can be replaced by a short circuit with the current source I naught. You have to remember both the conditions. Without initial current, with initial current. Without initial current, inductor will be act as a initially open circuit, and if you have initial current, then it can be act as a current source I naught. That inductor can be replaced by I naught. But while coming to the steady state or final condition, that is at t is equal to infinity, inductor will be act as a short circuit. If the inductor current is I naught, that is initial current is I naught, that can be replaced by inductor with a short circuit in parallel with the current source I naught. These properties you have to follow for the inductor element. So initially inductor act as an open circuit, at steady state inductor act as a short circuit. You just keep in mind. Coming to the next element, capacitor. So again, I'm going to take a capacitor voltage is V of t and current through the circuit is I of t. Again, I'm going to take a switching instant, t is equal to 0, the switch is closed. What is the inductor voltage, capacitor voltage initially and capacitor voltage at final? Why should I select current is for an inductor, voltage is for capacitor? Means inductor always stores the energy in the form of magnetic field. That means the energy stored in inductor is always depends upon E is equal to half Li square. Half Li square. For the capacitor, if you want to find the energy stored by the capacitor is E is equal to half CV square. Half CV square. It indicates inductor always stores the energy in the form of magnetic field. Capacitor will stores the energy always in the form of electric field. So that's why I can take for capacitor is voltage, for an inductor is current. So here also I'm going to take same condition when the switch is closed. So no need to go through all these expressions. You just remember what I'm going to say. Let us take first. Before closing the switch, that means at t is equal to 0 minus at t is equal to 0 minus means before closing the switch, what is the capacitor voltage? The capacitor voltage is 0. The capacitor voltage is 0. 110 works. ఆఫ్టర్నూన్ చెప్పాను, లంచ్ తర్వాత రమ్మని చెప్పాను. At t is equal to 0, the capacitor voltage is 0 because initially the switch is open now. Now, when you close the switch at t is equal to 0 plus, that means after immediately closing the switch, what is the capacitor voltage? Again, thus capacitor cannot change instantaneously. Therefore, it cannot allow such sudden changes in the voltage. So obviously, the capacitor voltage is 0. Now, what is the next instant? That means the capacitor now, for t greater than 0, the capacitor starts charging. The capacitor starts charging in the sense it is moving. Now the capacitor will store the energy like this. Now keep on increasing time t. At t is equal to infinity. At t is equal to infinity. Now what is the action of capacitor? At t is equal to infinity means capacitor can store the full energy. That's the maximum energy it can store. So that this capacitor, now if I take I is equal to C dV by dt. I is equal to C dV by dt. That is the current through the capacitor. So when you charge capacitor fully, it indicates this voltage will become constant. That means 100%. If it is constant, then the current through the capacitor is 0. And the current through the capacitor is 0. If the current through the capacitor is 0, that means current through this capacitor is 0. It will be act as a open circuit. It will be act as a open circuit. Therefore, initially, when you close the switch immediately, the capacitor voltage is 0 means it acts as a short circuit. And for a t is equal to infinity, the current through the capacitor is 0. That means it acts as a open circuit. It acts as a open circuit. Therefore, it is quite opposite to the inductor. That means there we have discussion. So, therefore, V of 0 minus is equal to V of 0 plus means in both the cases the capacitor voltage is 0 because that capacitor cannot change instantaneously. This means whatever the energy available in the capacitor at before closing the switch, after immediately closing the switch is to be same. So when the capacitor voltage is 0 means initially, then the capacitor will be act as a short circuit. Now this is a symbol for representation. Initially, this is a capacitor. When you close the switch immediately, that initial capacitor will be act as a short circuit. At t is equal to 0 plus. Short circuit in the sense we have to draw a straight line. Now here also I'm going to take, if the capacitor having some initial charge V of 0, and it replaces completely voltage source. It can be replaced like this. That means if the capacitor without charge, initially it will be act as a short circuit. With charge, it can be act as a voltage source. That we have to remember. At steady state condition, that is at t is equal to infinity. At t is equal to infinity means I is equal to C dV by dt. Then if you substitute t is equal to infinity means this current will be act as a, d by dt will become 0. That means I of 0 is I of t will become 0. This means at t is equal to infinity, our final or steady state capacitor will be act as an open circuit. Therefore, the final condition equivalent circuits of capacitor as shown in figure. That means element of inductor, capacitor. This is a capacitor at steady state. It can be replaced by an open circuit. So at t is equal to infinity, the capacitor will behave like an open circuit. Even though if it is having initial charges V of 0, now at steady state it can be replaced by a voltage source and with an open circuit. So by combining 4 elements or 3 elements with all modifications, then we have a simple table. From the table, you can understand every point. Let us take that point. I'm going to take first one. So first one is an element. Second one is a symbol. Third one is equivalent circuit at t is equal to 0 plus means after immediately closing the switch. T is equal to 0 plus means after immediately closing the switch. What is the behavior of 3 elements? This one is at t is equal to infinity. T is equal to infinity means after fully charging, that is finally fully charged. What is the behavior of resistor, inductor and capacitor? So coming to the first one, resistor, symbol is represented like this. At t is equal to 0 plus, there is no change in the resistor. At t is equal to infinity, there is no change in the resistor, because that resistor cannot store the energy. Here we do not consider any initial value or final value for the resistor element. There is no change in voltage or current for the resistor element. No need to change. అంటే మీరు అప్లై చేసిన వోల్టేజ్ కానీ కరెంట్ కానీ రెసిస్టర్ ఎలిమెంట్లో చేంజెస్ ఏమి ఉండవు. రెసిస్టర్ వాల్యూ చేంజ్ అయితే ఆటోమేటిక్గా పారామీటర్స్ చేంజ్ అవుతాయి, బట్ విత్ రెస్పెక్ట్ టు టైంతో మాత్రం అవి చేంజ్ అవ్వవు. సో దట్ ఫర్ ద రెసిస్టర్ వీ కెనాట్ కన్సిడర్ ఇనిషియల్ అండ్ ఫైనల్ కండిషన్స్. Coming to the second one, what is the second one? Inductor. So inductor, here I am going to take without initial current. That is, initial current is initially 0. Without initial current in the sense it is 0. అంటే మీ మొబైల్ ఫోను 0 ఛార్జింగే ఉందనుకుందాం. That time the symbol for inductor is like this, which is represented by the letter L. At t is equal to 0 plus means after immediately closing the switch. So this is after immediately closing the switch at t is equal to 0 plus. After immediately closing the switch, the current through the inductor is 0 generally. So 0 means it will be act as a open circuit. So at t is equal to 0 plus, inductor will be act as a open circuit. Keep in mind. So inductor will be act as a open circuit because it cannot allow instantaneous changes in the current. That means it cannot allow sudden changes in the current. That's why inductor behaves like a open circuit at t is equal to 0 plus. Now at t is equal to infinity, that means final. That means after fully charged, you can take this is fully charged. Fully charged. You can take this is fully charged. So at that instant, this inductor can be act as a short circuit. SC means short circuit. Why it is act as a short circuit means previously we had discussion. So inductor voltage will become 0 because V is equal to, we are having the expression is L into di by dt. L into di by dt. So at t is equal to infinity means when I substitute t is equal to infinity in the denominator and the voltage will become 0. If the inductor voltage is 0 means that element will be act as a short circuit. Therefore, at t is equal to infinity, that inductor will be act as a short circuit. So initially it act as a open circuit. At steady state it act as a, or final state it act as a short circuit. And these discussions only for an inductor without initial condition, initial current. That is initial value, initial current is 0. That is your mobile phone is 0 charging. So ఇప్పుడు మీ మొబైల్ ఫోన్ ఉంది, మొబైల్ ఫోన్ ఛార్జింగ్ లో పెట్టిన వెంటనే వాట్ ఈస్ ద పర్సంటేజ్ ఆఫ్ యువర్ మొబైల్ ఫోన్?
0.
0. So 0 in the sense it should be act as an open circuit. Okay. Now fully charged, 100% charge అయినప్పుడు మొబైల్ ఛార్జ్ ఎంత ఉంటుంది? 100% ఉంటుంది. So that 100% means we are going to disconnect the supply. That means supply voltage is 0. Supply voltage is in the 0 in the sense it should be act as a short circuit. Therefore, an inductor will be act as an open circuit initially. At steady state, it act as a short circuit. This is only for initial charge in the phone or the inductor is 0. అంటే initial current 0 ఉన్నప్పుడు మాత్రమే ఇలా తీసుకోవాలి. When you take inductor with an initial current I0, That time how to replace an inductor at t is equal to 0 plus at t is equal to infinity. So at t is equal to 0 plus, that inductor can be replaced by that initial current, whatever the initial current is available, that we can take like a current source. At steady state condition, that initial current in parallel with short circuit we are going to replace. That is, the inductor can replace it by a short circuit with initial current I naught. That means మీ మొబైల్ ఫోన్లో 5% ఛార్జింగ్ ఉందనుకోండి, that time that inductor can be replaced by 5%. Then steady state కూర్చోలేకే that inductor can replace it by short circuit, that too in series with the initial current 5 amperes. So this is a difference between both without initial current and with initial current. You have to remember both the conditions. In both the cases, how the inductor can be replaced at t is equal to 0 plus at t is equal to infinity. Coming to the capacitor, again I am going to take, if you take capacitor, I can consider voltage V naught, the capacitor voltage. So without V naught, in the sense the capacitor voltage is assumed to be 0. So the symbol of capacitor is like this. At t is equal to 0 plus means initially capacitor will act as a short circuit because the voltage is 0. When the voltage is 0 means it should be short circuit. Therefore, the capacitor will behave like a short circuit because it does not allow us sudden changes in the voltage. So the capacitor behaves like a short circuit initially. And finally, at t is equal to infinity, same capacitor can be behaves like a open circuit. Quite opposite to the capacitor, I mean inductor. It behaves like a open circuit. Why it is behaves like a open circuit means we already know that current equation I is equal to C dV by dt. C dV by dt. Here I am going to take a t is equal to infinity. When I substitute t is equal to infinity in the denominator and it becomes 0, that is the current through the inductor is 0. Though the current is 0 means that is to be open circuit. Therefore, at steady state, that capacitor behaves like a open circuit. This is all for without initial voltage in the capacitor. If we consider with voltage, let's say initial voltage in the capacitor is V naught, that time this capacitor can be modified as same, that capacitor can be replaced by the voltage source V naught, and in steady state that capacitor can be replaced by V naught with open circuit. So you have to remember this table, and it gives complete information about 3 elements: with charge, without charge, and behaves at the time of instant closing the switch, at the instant of fully charged. That means final value. So we have to remember what is the behavior of inductor and capacitor initially and finally. So better to note down, please note down this table, and it gives full information about 3 elements: how the resistor or inductor or capacitor behaves initially, how the resistor, inductor, capacitor behaves, and finally how we can replace those elements. Suppose in the given circuit initially unknown ankondi, inductor will be act as an open circuit. So therefore we have to disconnect the inductor from the circuit. Capacitor will be act as a short circuit. Therefore we have to join the capacitor with a straight line. Like that you can understand. For that reason only, all of you please note down this table. After this we will continue in the next class. Please note down this table, all of you. Just note down this table, then we'll continue in the next class. I will give just 2 or 3 minutes to note down this table. Thank you.
Hello.
Completed, sir.
Is it okay, all of you?
Yes, sir.
Okay, thank you. We'll discuss in the next class.
Thank you, sir.